Hi everyone, welcome you to the lecture 4 of the chapter Motion in a Straight Line. And in this lecture, we are going to discuss the numerical question based on our lecture 3. So let's see what all are the questions that we are going to discuss today. Here is the first question for you. During a hard sneeze, your eyes might shut for 0.5 seconds. If you are driving a car at 130 km per hour during such a sneeze, then how far does the car move during that time? Okay, so this question is very simple. Let us write which all are the given data. Okay, let's write what is the given data. Here in this question, a person is driving the car and he had a hard sneeze. Okay, and the speed with which he is driving is given to be 130 km per hour. Okay, you need to convert it into meter per second. Why? Because kilometer per hour is not the SI unit. So in order to convert, okay, you have to note, to convert kilometer per hour to meter per second, you just multiply using 5 by 18. Okay, and now to convert from meter per second into kilometer per hour, you have to multiply by 18 by 5. Okay, you have to remember these 2 points. And now let's see how to do this. We want to convert this 130 km per hour into meter per second. Okay, so it is 130 multiplied by 5 by 18. Okay, you can cut this with the 2. So upon cutting, here you will get 65 by 5 divided by 18. 18 cut with 2, you get 9. Clear? So this much meter per second. Now what is the time taken? The time for the sneeze is given to be 0.5 second. Okay, 0.5 second, 0.5 second, 0.5 second, or you can write it as 1 by 2 second. Okay, I think basically the calculation with the decimal is somewhat tough than the calculation with the fraction. Okay, so I will be converting decimal into fraction for doing problem. So 0.5 is decimal. So the fraction is 1 by 2. Okay, so 1 by 2 seconds. Now you need to find how much this car will move when the eyes is shut. Okay, so you need to find the distance. You need to find the distance. Okay, distance. So how to find the distance? You know that the equation is speed is equal to distance by time, right? Speed is equal to distance by time. So what about the distance? Your distance will be equal to speed into time, right? Speed into time. What is the speed in the question? The speed is 65 multiplied with 5 by 9 into your time is 1 by 2. Your answer will be, let's calculate it. Okay, you should not use calculator because you are going to write competitive examination as well as board examination, so you will not have calculators with you, but I am using calculator not to waste the time. Okay, so let's do it. 65 into 5 divided by 9 times 2. Your answer is 18.05 meters. Clear? So this is the distance with which the car will move. It move 18 meters. Think of the situation, right? If you just had a sneeze, then the car will move 18 meters. It's a very long distance, right? Yes. Okay. Now let's see what is the next question. The next question is, a train that is 100 meter long is moving with a speed of 60 km per hour. In what time shall it crosses a bridge of 1 kilometer long. Okay, so this is a very easy question, and also it's a conceptual question too. Okay. Okay, so let's see that question. There is a bridge and the length of this bridge is given to be 1 kilometer. Okay, you know the SI unit is meter, so we will convert it. We know it is equal to 1000 meter, right? So this is our bridge, and we have a train. Okay, this is the train. Oh, this seems to be a train, right? Okay, here is a train, and okay, this train is moving with a speed. Okay, the speed is given to be 60 kilometer per hour. Clear? 60 kilometer per hour, and you know that is not the SI unit, so you have to convert it. So speed 60 kilometer per hour multiply by 5 by 18. Clear? So you can cut this with a 6, so this become 10, and the denominator will become 3, so it is 50 by 3 meter per second. Okay, and the length of the train, yes, is mentioned in the question as 100 meter. Okay, the train have a length 100 meter. Clear? Now the question is, what is the time taken for this train to cross this bridge? Clear? So let me ask you something. What is mean by crossing? Okay, crossing means the train should completely pass this bridge, right? So I will tell you, if it is something like this, assume like this, if the train is like this, then now do the train cross the bridge? No. Why? Because the front of the train is at the end of this bridge. The remaining length of this train is still on the bridge, right? So this train did not pass the bridge. Now, in order to pass the bridge, the back of the train should be at the end of this bridge. Clear? Now see. Now the train passed the bridge. Clear? Then what is the total distance the front part of this train should cover? This is already 1000 and this is 100. Clear? So the total distance will be 1100 meter. I hope you got the concept. Clear? So when this train pass the bridge or cross the bridge, the train should cover a distance of 1100 meters. So you write distance 1100 meter. Now you need time, right? What is the equation? Yes, the basic equation itself. Speed is equal to distance by time. So from this equation you can tell your time is equal to distance by speed, distance by speed. What about your distance? It is 1100 by your speed is 50 divided by 3. So this becomes 1100 multiplied by 3 divided by 50. You cancel these zeros. Okay. In 110, in 11 it is 2 times. Right? Then you have 10 remaining. So 2 multiplied by 3, you get 66 seconds. Okay. So 66 seconds is the answer. Within 66 seconds, the train can cross this bridge? I hope you understand this question. Okay, and the key of this question lies in finding the distance. Okay, if you got the distance, then the rest is easy because you know the basic equations. Clear? Now let's see what is our third question. Okay, here is the third question. A car cover the first half of the distance between two places at 40 km per hour and the second half of the distance at 60 km per hour. Now you have to calculate the average speed and average velocity. Clear? This is also a very simple question. It is based on the concept of average speed and average velocity, and we are already familiar with the equation, and I have tell you two cases. Okay, so let's see how to do this question. Okay. Okay, so as per the question, there is two places. Let the first place be A and the next place be B. Okay, and a car, right? It's car, right? Yes, a car. A car cover first half of the distance. Okay, first half of the distance. So this is the total distance. The first half, so let it be the half. Okay, first half with a speed 40 km per hour and the second half with a speed 60 km per hour. Clear? Now you are asked to find what is the average speed and what is the average velocity. Okay, so in order to do this problem, we have two methods. Okay, so the easiest one among them is using the case I have tell you. Okay, in this situation, distance and displacement are same, right? In this situation, distance is equal to displacement. Am I right? Distance and displacement are same because the vehicle is moving in a straight line. Okay, from A to B. So you can say your average speed will be equal to the average velocity. Okay, so average speed and average velocity will be same because your distance and displacement are same. Clear? Because the car is moving in a straight line from A to B. Clear? So you can say your average speed or average velocity, everything will be equal to 2uv by u plus v. I hope you remember this formula, right? 2uv by u plus v. And now 2 into, what about u? U is 40. Okay, so 40 multiplied by 60 divided by 40 plus 60. So this is 2 into 40 into 60 divided by 40 plus 60 is 100. So you cancel these zeros. So 2 into 4 is 8 and 8 into 6 is 48. So your answer is 48 kilometer per hour. Okay. So this is a very simple question. So this is the first method of solving this question. Okay. Using the equation that we have discussed by telling you two cases, you remember, right? Now let's see what is the another method to do this question. Okay, yet the second method is, and you should note both these methods. Okay, now second method, let the total distance be d. Okay, total distance be d. Then your AC will be equal to d by 2. Clear? And your CB will be also equal to d by 2. Okay. So what is the equation for average speed or average velocity? In this case both are same. Okay. So you find one and tell them the distance and displacement are same, therefore both average speed and average velocity is the same answer. Okay. And we now already know the answer, it is 48. So let's see how to get that. Okay. You know average speed is equal to total distance by total time, right? Total distance by total time, right? What is the total distance covered? Yes, D is the total distance. And what about the total time? Okay, so we need the time to cover AC and the time to cover CB, right? So that is nothing but time to cover AC plus time to cover CB, right? How to find time? The time equation is, you know, speed is equal to distance by time. So your time will be equal to distance by speed, right? Distance by speed. So let's substitute that D by time for AC. What is the distance of AC? AC distance is D by 2 by. What about the speed? Speed is 40, right? 40. So that is the time for covering this AC distance. And time to cover CB distance. What about that? What is the distance? Is again D by 2. And what about the speed? Is 60, right? 60. How to do this? Yes, you know that. From the denominator part, you can take this D common. The remaining will become 1 by 80 plus 1 by 120, right? So both this D will cancel. Okay, so here remaining is 1. Now what about the denominator part of this fraction? The denominators are not same, so you have to cross multiply them. So what you get? Upon cross multiplying, it becomes 1 by, just multiply this, 120 plus 80 by 120 into 80. Am I right? Now this 120 into 80 will go to the top. Okay, so what happens? It becomes 120 into 80 divided by, upon adding you get 200. So this 0, this 0, this one, this will get cancelled. Now 12 by 2 is 6 times 8, right? 12 and 2 will cancel, you get 6. 6 multiplied by 8, you get again 48 km per hour. Okay. So this is the required answer. Okay. So in this way also you can answer this question. Okay. So the average speed and average velocity both are 48 km per hour. Clear? Now let's see what is the next question. Okay. So our fourth question is, an engineer start his journey from office to work site and travel with a speed of 60 km per hour. Then he or she return back to the office at a speed 40 km per hour. Okay. You calculate the average speed and average velocity. So that's the question. Calculate the average speed and average velocity. Okay. So again, let's see how to do this question. Yes. Now the question says there is an engineer and let this be his office. Okay. From office to work site. So here is a work site. So from office to work site, his speed is U is equal to 40, right? Office to work site, yes, 60. Okay, so that is 60 kilometer per hour. Then he returned back to his office at a speed which is equal to 40 kilometer per hour. 40 kilometer per hour. Okay, now you want to calculate the average speed and average velocity. Clear? Now let's see how to do this question. In this question, first let's find the average velocity. Okay, what about the average velocity? What about the average velocity? We know that average velocity is basically total displacement by total time taken, right? What about the displacement in this situation? The person's initial position or the engineer's initial position is his office. Okay, now from office he moved to work site and returned back to the office, which means the final ending point is also the office itself. So the displacement, okay, we know this is displacement by time, and the displacement is 0. Now whatever be the time, you are dividing 0 with anything, your answer will be 0. So your average velocity is 0. I hope you get that concept. Okay, because in this situation the displacement is 0. Ready? Now what about the average speed? Okay, average speed. Now in this question the distance is halved, right? Why? From office to work site, okay, from office to work site, if the distance is d, then from work site to office the distance is same, d. Okay, so out of the total distance is 2d. Okay, out of the total distance 2d, the first half distance is moved with velocity 60 and the next half is moved with a velocity 40. Then what will be the average speed? Yes, 2uv by u plus v, right? So how to do this? 2 times u is 60, 40 by 60 plus 40, that is 100, right? Cut this, your answer become 48 kilometer per hour. Clear? Kilometer per hour. So that's the answer. I hope you understand the concept of this question. Okay. Now let's read the last and final question of this lecture. Question number 5. Okay. A car is moving along a straight line, say OP in figure. Okay. It moves from O to P in 18 seconds and return from P to Q in 6 seconds. What are the average velocity of the car in going from O to P, then from O to P and back to Q? Okay, you have to find the average velocity. Okay. Now you have a number line there. Okay, so let's draw that. So there is a number line and you have 3 points O, Q and P. Okay, I am not marking each and every point, I am just marking these points only. Okay, so your O is marked to be 0, so let it be O. here Q, and here P. Okay, and your Q is 240 and your P is at 360. Okay, and now from O to P the time is given. Okay, the time is specified, that is O to P the time taken is O to P the time is 18 seconds. Okay, and from P to Q, okay, P to Q the time mentioned in the question is 6 seconds. Clear? Now you are asked to find the average velocity. Okay, so what about the A question? The average velocity, okay, you have to find from O to P. So O to P, what is the average velocity? The equation for average velocity is total displacement by total time. What about the displacement from O to P? The displacement is 360. Okay, so let's assume this is in meter. So that is 360 by the time taken from O to P is 18. 36 by 18 is 2, so that is 20, right? So 20 meter per second is your answer of average velocity from O to P. Okay, it's a very simple question. Now what about the B question? From O to P and back to Q. Okay, back to Q. O to P. Okay, O to P then back to Q. Then what about the displacement? Okay, so we want to find average velocity. Average velocity is total displacement by total time. Okay, while you are writing in the notebook, you have to write it completely. Okay, now for time saving I am just making it short. Okay, so total displacement from O to P, or either you can find it in two ways. This is the initial position and this is the final position. Okay, so the displacement is this, which is equal to 240, and you are measuring in the right direction, so that is taken to be positive. Okay, and if you are measuring the displacement in the left, it should be considered as negative. That's all. So your displacement is 240 divided by, okay, what about the total time? The total time is, first O to P the time is 18, P to Q the time is 6, so it will become 18 plus 6. Clear? So that is nothing but 240 divided by 18 plus 6 is 24. So your answer is 10 meter per second. Clear? 10 meter per second. So here from this lecture, the concept of speed and distance as well as average speed and average displacement is covered in these questions. I hope you understand this all. And now let's see you all in the lecture 5. Bye bye.